So today we will discuss about area vector. Now till now in all the physics, whatever mechanics we have studied, we always treat area as a scalar, right? Area is a scalar quantity, length is a scalar quantity, volume is a scalar quantity. But there are so many applications, so many situations in which we need to find the direction of the area, and it is very, very important. Say for example, say I have taken this area, right, and there are so many electric field lines crossing this area, right? Now if I change the direction of area like this, if I am changing the direction of area like this, so जो electric field lines यहाँ से जा रही थी, now they will not be able to pass. Now say suppose 100 electric field lines were crossing here through this area, and I have changed it to 45 degree. Now only 50 are passing. Now I have changed it to 90 degree. Now hardly 1 or 2 electric field lines will pass through this area. So we say that in physics also we need to treat area as a vector quantity in some situations. So now we are going to learn how we can treat area, which is a scalar, how we can treat it as a vector. So we will learn about area vector and how changing the area is going to affect the electric field and the number of electric field lines passing through the given area, right? So what we do to convert area into area vector is, suppose we have taken this area, any area, this is a given area. Now what we do, we consider that there is a unit vector perpendicular to the surface. There is a unit vector perpendicular, say this is the area, I want to express it as a area vector. So I will draw a unit vector perpendicular to its surface. अभी अगर एरिया ऐसे है तो यूनिट वेक्टर ऐसे होगा, एरिया अगर बेंड हो गया तो यूनिट वेक्टर का ये हमेशा परपेंडिकुलर रहेगा. This unit vector will always be perpendicular to the surface. So if area is like this, unit vector is along the direction of electric field. If I am changing the direction of the area, unit vector का angle change हो जाएगा. Change, angle different, and so on. So how do we express a given area in terms of area vector? We take a unit vector which always remains perpendicular to the surface of the area component, right? And how do we express it mathematically? Suppose this is the area. Let us name this as A or ds. Let us name this as ds. Now this ds is a scalar. अगर हमें ds को vector quantity बनाना है, if we want to convert it to vector quantity, we will write its magnitude into unit vector n. Now we will say that this is area vector. Why? Because it has a vector component along with it. And what is this vector component? This vector component is a unit vector which is perpendicular to the surface. Say any area A. How to express it as area vector? We will write the magnitude of A and unit vector n. So what is vector A? Vector A will be A with unit vector n. A means, no vector means it is the magnitude. So in so many applications we are going to discuss the area vector, right? As we are changing the surface, this fixed part will also keep on changing, but in any condition it will always be perpendicular to the surface. Hence we treat it as area vector, right? Proceeding, the next topic is electric flux. Electric flux. Say suppose we have taken a particular area, this is a particular area dotted, and in this particular area I say that suppose 100 field lines are passing, right? Then we say that the number of field lines crossing a given area. How do we find? What is the quantity by which we measure कि ये वाले area का कितनी field lines इसमें से pass हो रही हैं? So that quantity is called as electric flux, right? So electric flux through a given area tells us about the number of field lines held or passing through that area, right? Again, the unit vector n, if I am taking this as ds, though this unit vector will be perpendicular to the surface, and obviously when I change the direction of ds, when I change the direction of area component in terms of vector, the number of field lines will be less. As I told you, so suppose when the area vector, I am calculating the electric field lines from here. if it is kept like this, say 100 field lines are passing, I am changing it to 45, 50 are passing. Now only 30 field lines are passing. Now I have kept it here, 0 field lines are passing. So हमने area को कैसे रखा है electric field में, that depends and that tells us how many electric field lines will cross the given area, right? So the measure of total number of field lines crossing a given area is called as electric flux. How do we calculate electric flux? We calculate electric flux by writing E dot ds. Flux is a scalar quantity. Scalar quantity means it can be expressed as a dot product or scalar product. So it is the dot product of electric field. We have studied about electric field and the area vector. This sign has been used. This is the integration sign. So I am taking this part, I am integrating the whole part, and this part tells us that the surface is the closed. We are taking ये closed surface में से कितने field lines pass हो रही हैं. So we express this as a closed surface integral. This means closed surface integral. Surface means we are talking about the area vector and we are taking the surface here. So electric flux is numerically equal to the closed surface integral of electric field. Right? Bio students especially, if we are taking this as the simple integration, if we are writing this, it means we have taken the surface integral of a closed surface. We are considering it as a closed surface. So phi is equals to E dot ds. Closed surface integral of electric field is called electric flux. So let us find its SI unit. Its SI unit will be, yes, what is the SI unit of electric field? Newton per coulomb into surface meter square. So its SI unit comes out to be Newton meter square per coulomb or Newton meter square per coulomb. This is the SI unit of electric flux. Children, electric flux is very important term because you are going to study electric flux. If you understand electric flux, then Gauss theorem will become very easy to you. Now the next topic we are going to take is Gauss theorem. Right? Any doubts still here? You may ask.